Hello everyone, welcome to 21EC402 microprocessor and microcontroller, and this is unit 2 8086 system bus architecture. This is presented by Manimeglayal, assistant professor ECE from R.M.K. CT. So in this lecture we are going to discuss about the 8086 signals, that is 8086 pin diagram. So let us move on to the lecture. So we all know the Intel 8086 microprocessor is having 40 pin dual inline package. So we can see here the 40 pins of 8086, that is it starts from 1 and ends at 20 on one side and from 21 to 40 on the other side. So here we are having two different categories of pins from 31 to 24. So one stands for the maximum mode and another one stands for the minimum mode of operation. And we have from pin number 2 to pin number 16 the multiplexed data and address space, and the pin number 35 to 39 we have the address lines alone. So let us discuss about it briefly. So here we'll be having two ground pins, pin number 1 and 20, and the clock cycle is given within the clock pin, that is pin number 19. The operation of 8086 will be off with 5 MHz, 8 MHz or 10 MHz, and the duty cycle of the clock of 8086 is 33%, and it operates in plus 5 volt with tolerance of plus or minus 10% VCC, and we have a reset pin. So when the reset pin is kept high, the content of the code segment and the instruction pointer is set to FFFF for the code segment and all zeros for the instruction pointer. So these are the values loaded within these two registers when the reset pin gets high in 8086. So, and the reset should remain high for minimum 4 clock cycles in 8086. So this is one of the non-maskable interrupt available in 8086. So reset will be setting the values of registers, segment registers and the flags in 8086. So here we are highlighting the multiplexed address and data lines. So you'll be having 16 bits of data lines for the 8086 and 20 bits of IO address for the 8086, and the other pin ALE stands for the address latch enable pin. This address latch enable pin is the output signal. It indicates the availability of the valid address on the address or data line, and it is connected to the latch enable input of the latches of 8086. This signal is active I and it is never tri-stated. The next set of pins would be non-maskable interrupt pin NMI, pin number 17, and pin number 18 is interrupt request INTR pin, and pin number 24 interrupt acknowledgement pin. So this non-maskable interrupt NMI pin is a edge triggered input pin which causes the type 2 interrupt. So this non-maskable interrupt is not masked by any software internally. So here the transition from low to high initiates the interrupt response at the end of the current instruction. and this input is internally synchronized. And talking about the interrupt request pin, this is a level triggered input pin. This is sampled during the last clock cycle of each instruction to determine the availability of the interrupt request. If any interrupt request is pending, the processor enters the interrupt acknowledge cycle. So this can be internally masked by resetting the interrupt enable flag of 8086, and this signal is always active high and it is internally synchronized. Talking about the interrupt acknowledgement, this signal is used for reading the interrupt acknowledgement cycle. In other words, when it goes slow, it means that processor has accepted the interrupt. The next is HLD Hold Acknowledge and HOLD Hold. So these pins are used for the direct memory access. So talking about the direct memory access, when the hold pin goes high, it indicates to the processor that another master is requesting for the bus access. So the processor, after receiving the hold request, issues the hold acknowledgement signal from the HLDA pin of 8086. So the next sets of pins would be the higher order address lines and the status lines. So higher order address lines is from A16 to A19, and the status lines are from S6 to S3. And here these lines are time multiplex address and status lines. During the IO operations, these lines are low. During the memory operations, status information is available on these lines for the T2 clock cycle, a T3 wait state, and the T4 clock cycle. So this S4 and S3 together indicate which segment register is presently being used for the memory access. So we can see here the table. This S4 and S3 combination determines the segment to be used. So when it is both are 0, we are using the extra segment, and when S4 is 0 and S3 is 1, we are using the stack segment, and when the S4 is 1 and S3 is 0, we are using the code or none of the segments, and when S4 is 1 and S3 is 1, meaning both are high, the data segment is being selected. And S6 is always a low, that is logic 0, and S5 indicates the condition of the interrupt flag bit available in the flag register. So this is all about the address and status bus. The next signal is the bus high enable or the S7 signal. So the bus high enable signal is used to indicate the transfer of data over the higher order data bus, that is D8 to D15 of the data bus, and it goes low for the data transfer over the D15 to D8, and it is used to derive the chip selects of odd address memory bank or the peripherals. So this bus high enable is low during the T1 cycle for read, write, and interrupt acknowledgement cycles, and whenever a byte is to be transferred on the higher byte of data bus, this becomes low. The status information is available during the T2, T3, T4 of the clock cycle, and the signal is active low and it is stated during the hold. So here we can see the bus I enable and the A0 combination. When the bus high enable 0 and A0 is 0, you can select the whole word to be transferred in the data bus, and when it is 0, that is when BHE is 0 and A0 is 1, higher byte you can transfer from or to the odd address, and BHE is 1 and A0 is 0, lower byte is transferred to or from the even address. And when both are high, none could be done using this higher order data bus. And the next is the maximum and minimum mode selection pin. So there are two modes of configuration of 8086. The minimum mode is getting operated when plus 5 volt is connected to this pin, and the maximum mode is allowed when it is connected to the 0 volt or grounded. So you can see the combination of this minimum mode pins from hold to INTA. All this category comes under the minimum mode of operation, and this request pin to queue status pin 1 comes under the maximum mode of operation of 808. The next class of pins will be read signal, write signal, memory and IO signal, data transmit and receive signal, and the data bus enable signal. So the read signal when low indicates that the peripherals, the processor is performing a memory read or IO operation. So the read signal is active low signal. And then we have the write signal. So write signal is the opposite of the read signal, where the data is read from a peripheral. And memory or IO, this is the status line logically equivalent to S2 in the maximum mode. When it is low, it indicates the CPU is having an IO operation, and when it is high, it indicates that the CPU is having a memory operation. And then data transmit and receive. This output pin is used to indicate the direction of data flow through the transceivers. When the processor sends out the data, the signal is high, and when the processor is receiving the data, the signal is low. And data bus enables DEN pin. This signal indicates the availability of the valid address over the address or data lines. It is used to enable the transceivers to separate the data from multiplexed address and data line. And then the next signal is the status signal, that is S0 to S2 signal. So these are the status lines which indicates the type of operation being carried out by the processor. So here you can see when S2 is 0, S1 is 0 and S0 is 0, it is interrupt acknowledgement cycle. And when it is S2 0, S1 0 and S0 1 means it is reading IO port. And if it is 0 1 0, it is writing IO port. And S2 0, S1 is 1 and S0 is 1 means it is in the halt state. And S2 is 1 and remaining two pins are 0 means it becomes the code access mode. And S2 is 1 and S1 is 0 and S0 is 1 means it is read memory cycle. And 110 means it is write memory, and all are high means it is passive state. The next pin is the request and grant pins, that is DMA request and grant. These pins are used by the other local bus masters in the maximum mode, and it is used to force the processor to release the local bus at the end of the processor's current bus cycle. So both of the pins are bidirectional. And next is the lock pin. This output pin indicates that the other system bus masters will be prevented from gaining the access of the system bus while the lock signal is active low. This lock signal is activated by the lock prefix instruction and it remains active until the completion of the next instruction by the 8086. And next is the Q status. So we have two pins, that is QS0 and QS1. So this lines gives information about the status of the code prefix Q available in 8086. So these are active during the clock cycle, after which the queue operation is performed. So the combination of these two will indicate the status of the queue. When both are low, the queue is idle, that is no operation. When QS1 is 0 and QS0 is 1, the first byte of the opcode is available from the queue, and 1 0 means the queue is empty, and both are high means the subsequent byte of the opcode are retrieved from the queue. So this is all about the pins available in 8086, and thank you.